Part B of a homework question, balancing redox equations, asks you to take a look at solutions that might occur in basic solution. So again, I'm going to walk you through these steps. These are the same steps that are listed on page 171 in your textbook. These are for acidic solution, and I'm going to follow those same steps, and at the end we'll make an adjustment for the solution in basic solution. There's really no reason to do the whole process differently. You can learn one basic way and then make an adjustment if the reaction is in basic solution. So what I'm figuring out from some of your emails is that that list of steps is fine. It's just getting started and figuring out what is happening is really maybe the more challenging thing. So in this case, we have oxygen appearing in all these compounds, and the kind of standard rule that we're using is that oxygen, when it's in a compound, is assigned a charge of -2. This is really just a bookkeeping measure to try to figure out what is in fact happening during this redox reaction. So a -2 on oxygen means -8 here because there's 4 of them. The whole charge on the particle is -1. So what we can determine from that is manganese in this compound must be a +7. Which compared to this compound, we can see manganese is going to be something different. In this particle, the overall charge is 0. There was no charge on this particle when we started. Each oxygen is -2. In order for these charges to balance and equal 0, manganese must have been +4. Manganese charge is changing from 7. This is what we're looking at here, is the change from 7 to 4. That sets up our basic half reaction. The manganese particle, and these charges are really important. If you forget to put them, it's going to make it hard for you to double check and make sure you haven't made any errors. Manganese is going from 7 to 4, so it's being reduced, and it's being reduced by 3, so that means it must have gained 3 electrons. Then we can balance the oxygens, always with water. So I need 2 more oxygens over here, and that just introduced 4 hydrogens, so I need to stick those in as well. Okay, then we look at these other 2 compounds that contain sulfur, and we do the same thing. If oxygen is -2 and there's 3 of them, that's a total of 6 negative. The overall charge on the particle is -2. So sulfur must be +4 here. And over here in the sulfate ion we do the same thing, but there's 4 oxygens. That's a total of -8. The overall charge is -2, so sulfur must be +6. Sulfur's charge is going from 4 positive to 6 positive. Its charge is going up. That's the result of an oxidation. Sulfur must be losing 2 electrons. And then we balance our oxygens. We've got 4 here. We need another one over here. And hydrogens now, we just introduced 2 hydrogens, so I need to try to squeeze them in over here. All right, remember when hydrogens are added, they're added as hydrogen ions that have a positive charge. If I haven't made any mistakes at this point, everything in each of these half reactions should be balanced. The manganese should balance, the oxygens, the hydrogens, but a good way to double check is with charge. Everything on this side is neutral. Everything over here should also be neutral. 4 positives, 3 minus, and another minus. So we have 4 minuses, 4 positives. That balances. That's neutral to match this side. Down here we have an overall charge of -2, and over here we have -2, -2, +2. So these cancel each other out, and this is our overall charge on the right hand side. So they don't have to both be neutral, they just have to match. So whatever the charge is here, it must also appear here. So now I'm ready to add these two half reactions together, but I have to first make sure that the electrons gained equal electrons lost. So that means I've got to make these the same. That means I'm going to make them both 6 electrons gained, 6 electrons lost. To do that, I'm going to have to multiply everything here by 2, and everything here has to be multiplied by 3. Things could get kind of messy at this point, so I'm going to rewrite those down so I don't miss anything. That gives me 8 hydrogens, and I'm not going to write down the electrons because those are going to cancel at this point. 2 MnO4s, these are I guess they're permanganate ions. Two of these, and now 4 waters. 3 waters on this side. 3 of these ions, these are sulfide ions. Just trying to keep everything that's a reactant on the left, and everything that's a product can appear over here on the product side, and really just write it wherever you can squeeze it in. 3 sulfates and 6 H pluses. Alright, so if it appears on the right hand side and the left hand side, of course it cancels, or you can subtract them to where they cancel. So I'm going to go ahead and do that just to simplify things. 3 waters will cancel 3 of these, leaving me with 1. And 6 H's will cancel 6 H's, leaving me with 2. So if the question were to balance this reaction in acidic solution, we would be done. This would be it. The question, however, is a reaction that occurs in basic solution. So that means I have to continue, and for solutions that are basic, there's actually an abundance of hydroxides. So what you'll need to do is, for every H plus that you see, add the corresponding amount of hydroxides. But if you add them to this side, you must also add them to this side. What happens here when we add 2 hydroxides to 2 H's is we make 2 waters. An HOH is a water molecule. We also have 2 permanganates and 3 sulfites. On the right hand side, we have 2 MnO2, a water, 3 sulfates, and 2 hydroxides. That looks pretty good so far. The only thing left really is to cancel out waters, because we have them on both sides. Water here cancels a water here. So this is the final answer. These are your reactants, just 1 water, and your product includes all 3 of these particles. So work the problem just as an acidic solution, and then if you have hydrogen ions on one side, add the corresponding number of hydroxides to both sides. That makes waters, and then cancel out as you're able. To double check that we didn't make any errors, you could check every element, like 2 manganese, 3 sulfurs, 3 sulfurs, and so on. But don't forget to check the charge to see if the charge on both sides balances. This is a charge of neutral, 2 minus, 6 minus, a total of -8 on this side. The right hand side also balances. 3 of these is 6 minus, 2 hydroxides is another -2, a total of -8 also on the product side.